So what we do is we ignore the maximize the equal statement, and we just focus on this system of inequalities. And we graph it like we did a couple sections, well, actually last section. Remember the last two there? These last two inequalities are called what? Non-negative constraints. And they say to keep our answer in quadrant 1. Good. So the first inequality, 2x plus y equals 10, has an x-intercept at, good, and a y-intercept at, solid. Oh, geez, that's good enough. So if your original inequality has an equal to, you're going to draw a solid line. If it has a strict inequality, so no equal to, you draw a dotted line. And what that is saying is no points on the line are solutions. Shading above or below? Below. 0, 0 makes it true. 0, 0 is below. We're going to shade below. But as previously stated, we're going to keep our answer in the first quadrant. Next up, x plus y equals 6 has x and y intercepts at what value? 6. Also solid? That's the only one you get today. Hold the rest in. Why are you laughing? Shading above or below? That'd be terrible. Below. It's like everyone's concentrating not to sneeze in class or something. Got it. Keep it in the first quadrant. Okay. My graph is a little bit sloppy. Let me shade in the final feasible region here. Did I mention I really love how you can do this? It's awesome. How many corner points does our region have? Four. 1, 2, 3, 4. The green x-intercept is a corner point. Not the purple one, though. So there's a little space right in there. Don't shade that in. Remember, your feasible region cannot cross a boundary line. Yes. But as far as your final answer, it's got to be below the green and below the purple. And this little guy right here is not below the green. Yeah. Now, 3 of the corner points are nice. What point is this one? 0, 0. What point is this one? What point is this one? The green x-intercept. 5, 0. But now any of these floaters, do not base it off the graph because it might be fractional. So instead, we would have to find the intersection of the lines, x plus y equals 6 and 2x plus y equals 10. So we'd have to do algebra. You have 30 seconds. Go. I'm done. No pressure. And make sure you check your answer because that ordered pair must work for both equations. 4, 2. They intersect at 4, 2. So that's our fourth corner point. Questions on 4, 2? Sure. The fastest way, in my opinion, is to subtract the equations because what happens to the y's? They cancel. So what's x minus 2x? Negative x equals, what's 6 minus 10? Negative 4. So what does that say about x? X equals 4. Well, if x plus y is 6 and x equals 4, 4 plus what is 6? 2. 4, 2. Yes. So please, 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 if this is bad, you've got to raid 5152. Please also watch the videos because I have videos in the regular 1250 section called substitution method and elimination method. Watch those. Because as stated, this problem on your test worth a lot of points. And you don't want to get it wrong because you did not find the correct corner points. All right, that is all step 1. Step 2, I need to get rid of all this stuff. Step 2 and 3 go together. We're going to make a little chart here. On the left, we're going to have the corner points, x, y. Does not matter the order in which you put the corner points. Just make sure you're only listing corner points. Also, make sure they're in the format x, y. I've seen too many times where people will switch around x-intercepts. Instead of 6, 0 or 5, 0, they write 0, 5. Please be careful with that. On the right, we now consider the objective function. And all we do is we plug the coordinates into the objective function. So 0, 0 means x is 0 and y is 0. So if you put in 0 in for x and 0 in for y, what do you get for z? 0. Boring. What are you going to do? 0, 6 says x is 0, y is 6. 6. 5, 0. 20. 4, 2. We are trying to maximize. So according to step 3, pick the optimal solution based on, if you're trying to, in this case, maximize, so we want the largest optimal value. Which of these values are the largest? Which of the values are the largest? 20. 50 is not a value. It's a point. Good. That means 5, 0 is our optimal solution. $20 is the optimal value. Huh? The optimal value. Which, if you're going to open a store, that would be a good store name, optimal value. I have dibs on absolute value. I think it'd be an awesome store name. I would shop there. All right, that's it.